Hello, everyone. My name is Yamit. I'm talking on behalf of my working teammates. In order to present our project, our team is composed by Pretty, Ayla, Anirudh, and myself, all the students of West Virginia University and currently enrolled in the Data Science Master Program. Our project is based on a classification problem using a public dataset available in New South Wales government website. The field of this project is the education and schools classification in the New South Wales state. Specifically, we are using the ICSEA index to classify the schools in high, medium, and low level of the school education advantage, which gives an overview of the background of the students and similar groups. A value on the index corresponds to the average level of educational advantage of the school students' population relative to those of other schools. Research shows that key factors in students' family backgrounds, parents' occupation, their school education, and non-school education have an influence on students' educational outcomes at school. So our project is aiming to find which one of the models is the best classification in terms of the accuracy and splitting the classes. So in this way, people can use the ICSEA value to understand the levels of advantage or disadvantage that the students bring to their schooling based on these factors. It is important to note that an ICSEA value is not a rating of a school, nor does it measure or rate the staff performance, quality of teaching programs, or nature of the facilities. ICSEA is not a measure of student academic performance and does not measure school wealth. ICSEA was developed to enable fair comparison of NAPLAN results between schools by comparing performance in schools working with students with similar socioeducational advantage. It is possible to identify the different schools are making to the student attending to a particular school. This index also enables schools seeking to improve their students' performance to learn from other schools with similar students. So, the introduction. ICSEA is a scale which allows for a fair result comparison among schools with similar student. ICSEA stands for the community social educational advantage. As I mentioned, the aim is the objective of our study is to understand the factors which have an impact on the ICSEA values. For the data pre-processing, and to begin with, the average ICSEA value is set on 1,000 points. The lower the ICSEA value, the lower the level of educational advantage of students who got to this particular student. The higher the ICSEA value, the higher the level of educational advantage of students who go to this school in particular. The data consists of 2,211 observations and 45 variables. After our first approach to the dataset, we have narrowed the dataset to 26 original variables and 22,211 observations. The variables dropped consist of information relating to phone numbers, website, facts, and other information that we already have school code and identify the observation at school level. Electorate information consisting of address and phone numbers. Electorate area information help us to identify the district level location of the school that we already have this in town suburb, so it's not necessary. The objective of this study is not to understand the political affiliation, hence these variables have not been considered. Therefore, at this stage, we have only removed the variables which are not significant to our analysis or variables which hold the same information in different variables. Variable support class where the entire column is blank were dropped as well. The next step on this preprocessing part was to check for the null values and replace it or delete it. The authors have decided to replace the missing values in each variable with the median, using the level of schooling as grouping factor. We have picked the median as we will show later in the graphs. Later, the density of our target variable is skewed, and if we introduce the mean, this will push our values and furthermore affect the prediction, whereas median is not impacted due to string values. Also, transform our variables into numerical variables if it's possible. Significant variables like percentage of Aboriginal people, language background, and others came in a categorical form, and it need to be transformed in numerical. After this part, the data is ready to be visualized. From the graphs above, we can see that there is negative correlation between the number of family centers and the ICSEA value. In places like Western Sydney and far west of Hunter, New England, the number of facts that it refers to the familiar area communities centers is larger than other places, but the fact there is more places like this not necessarily helps the kids to get better performance at school. We can see also that the gender does not influence the ICSEA values significantly, but there is a slightly difference between boys and girls, being girls performing better than the boys. The remoteness in the state clearly showed that the schools with similar backgrounds in the two different groups are led by the Sydney metropolitan region. And it's also shown that the enrollment of the schools is between a range of 0 to 2,500 in level, and the level of schooling and the ICSEA value is between a range of 600 to 1,200. Support vector machine are a set of supervised learning methods used for classification, regression, and outlier detection. Support vector machine is highly preferred by many as it produces significant accuracy with less computational power. Here, we use SVM to predict the ICSEA values using all the variables. Effective in high-dimensional spaces, and different kernel function can be specified for the distinction function. Our objective is to find a plane that has the maximum distance between data points of the three classes. Hyperplanes are decision boundaries that help classify the points. Data points falling on either side of the hyperplane can be attributed to different classes, SVM linear and RBF. As a first run, using all variables, we consider that our model has 84.5% of using radial basis function, and SVM with all the variables. We get an accuracy of 83.8%. SVM classification, model parameter tuning, and cross-validation. We can see that the estimator using the linear kernel performed best compared to the RBF and polynomial SVM. By using hyperparameter tuning method, we arrived at the optimal parameters, resulting in higher accuracy results compared to just using linear or nonlinear SVM. Accuracy of the test sample is validation 85%. There was a slight improvement in the accuracy after tuning the hyperparameters. The confusion matrix of the model shows that the false positive, meaning that the probability to predict the wrong class, has decreased, and the predictions are more precise. The SVM classification model using Lasso, in order to select the significant variables and reduce the dimension of our dataset after running SVM using all the variables, we are using Lasso for variable selection. It can be used as a method of variable selection, and this kind of regression optimizes the cost function by reducing the absolute values of the coefficient using shrinkage. The coefficients will help us choose the variables which are useful to reduce the multidimensional dataset. We only retain the coefficients which are not equal to 0 and are contributing to determine the target variable. The rest of the variables with coefficients are discarded. We then run the SVM model with the variable select using Lasso regression. The accuracy of the model after selection of variables using Lasso is 83%. We did not see any improvement in this model after variable selection, as the accuracy before and after discarding the variables are almost very close. The future selection may help in terms of making this model more easy to interpret, but not improve the performance. Lasso regression helped to speed up the construction of it. Finally, the SVM classification model using the PCA or principal component analysis. We have used another feature selection method, principal component analysis, PCA, to check if the accuracy of the model can be improved. Since the data has a large number of features, using PCL will help us to reduce the dimensionality of the data and simultaneously preserve of the important information. Accuracy of FBN model using the PCA is 45%. Using PCA for variable selection methods does not improve the accuracy. In fact, the accuracy is poorer when we use PCA for variable selection due to the requirement of a large number of components to explain 99% of the variation of the data. For this study, we have also used KNN, which is a supervised learning technique for both regression and classification. KNN predicted test data by calculating the distance between the test and training data points. Key values explains the count of the nearest neighbors, and for this study, we used the value of 1 to 10. The graph on the left showed the accuracy score of using key values of 1 to 10. The highest accuracy score is 82% by using key 9. The two plots on the right show the minimum error rate. We wanted to check for the optimal value of K to improve the model, but as we can see, the accuracy score is similar to our predicted model earlier. Overall, KNN is much simpler and faster to do as compared to other more advanced machine learning techniques. However, KNN also shows that although the approach is more straightforward, it still gives high accuracy predictions. Our last model is neural network. This neural network, which is created with 3 dense layers, and the activation function that we use is the most common one, which is really rectified linear unit. The accuracy of the neural network model is 82.3%. Another model is NNUCNP or multiplier perceptron classifier. Activation function used is also ReLU, and solver is a stochastic gradient descent. The accuracy for this is 85%. Feed to train the network and use the return story object to plot the training and validation accuracy to determine whether we train it for sufficient number of epochs and see how well the network fit the data. Thank you.